All right, welcome to the second part of our study of alkenes. In this part, we're going to talk about the reactions of alkenes, which belong to really two groups, addition reactions and polymerization reactions. In the addition reactions, we have hydrogenations, which we've seen in a few questions before. We have the addition of halogens, such as bromine, chlorine, and iodine, and hydrations, where we're going to be making alcohols. And to make the cool plastics that we talked about in the last episode, that's the polymerization reaction. So by the end of this, we'll be able to understand the reagents and how this works for all these reactions. So the first reaction is hydrogenation, and that's simple. That's just adding a hydrogen molecule into the alkenes. And the product of that is going to be an alkane, as you can see over here. So here I got ethene, and the double bond is reactive. It's a weaker bond. So in the presence of a catalyst, such as palladium, that's an expensive catalyst, but there's a few other transition metal catalysts like nickel, platinum, or palladium. So with those catalysts and in the presence of high pressure of hydrogen and heat, you can then take that double bond, make it react with the hydrogen, and then fully saturate the molecule back to an alkane. So a hydrogen molecule takes the place of one of those bonds and adds into the molecule. All right, so a classic use of hydrogenation reactions is making margarine. So if you take oil, any vegetable oil, and you expose it to hydrogen and palladium with high heat, you'll turn it into margarine butter. Okay, and then we also use it for various other chemical reactions. All right, the next reaction is adding halogens like chlorine, iodine, or bromine into a molecule that has a double bond. So that remember that double bond is very reactive. Okay, it wants to break and form something a little bit more stable. So that bond itself is a little bit electron rich, and it can attack things like bromine and react with it. So halogens such as bromine, chlorine, and iodine can be added. Like, just imagine a molecule of bromine is being added in, and you can see that here the two bromine atoms from that molecule are added in to make a dihalide, and that's a halogenation. So instead of bromine, you can have chlorine, you can have iodine, and it would make a dihalide, so two chlorine atoms or two iodine atoms in the molecule, and that's a halogenation reaction. For that, you might not necessarily need a lot of heat, depends on how reactive the halogen is. So certain halogens are more reactive than others. That's part of the activity series, which you would have read in another chapter. So you got iodine, bromine, chlorine, and fluorine. I wonder if you can predict which one would be more reactive with an alkene. Would bromine react faster than chlorine? Let's see if you guys can try to figure that out. Okay, and the reaction mechanism for that, I'm just giving you this for if you were taking an organic chemistry class in university. Not only do you have to memorize what the reactions are, but you have to try to understand why they happen. Okay, so in this reaction, we drew it on the board before the break. In the double bond, you have a pi bond that's not quite stable. It will react with a bromine molecule to make this bromonium ion, and the remaining bromide ion, after that pi bond attacks the bromine, it kicks out the electrons and makes a bromine negative anion. That negative anion will come in and displace that bromine to make this dibromide. Okay, you can imagine a bromine with a positive charge is not that stable. It's screaming for electrons. So it's pretty easy for that bromine to come in, attack that carbon, and kick that out. That's what's called a reaction mechanism, a step-by-step mechanism showing why these reactions happen. Okay, for the higher levels, you're going to have to memorize a few of these reaction mechanisms by the end of this unit. Okay, the next reaction is a hydrogen halide addition. And that's, imagine you're taking an acid such as hydrochloric acid, iodic acid, or hydrobromic acid, and if you react it with any chemical that has a double bond in it, it'll react and add that molecule into the double bond. Okay, so here we have propene, one propene. Okay, that's reacting with hydrogen bromide. Okay, that molecule is adding in. Now it can add in two different ways. The hydrogen can go here, or the hydrogen of that molecule can go here. And as you can see from this diagram, the major product is where the hydrogen goes on the outside and not on the inside. And there's a principle for that. Okay, it's called Markovnikov's principle, where the hydrogen always goes to the carbon that has the most hydrogens to begin with. So in this case, this carbon has two hydrogens, that carbon has one. So this hydrogen is going to go to that first carbon because it has more hydrogens in it. And then the bromine is going to go to the middle one. Okay, and the reason why that happens is because that carbon that has most carbons attached to it would make the most stable positive charge after the hydrogen's added. That you would learn in university if you want to take organic chemistry. All right, the last, not the last reaction, the second last reaction is hydration reactions, where we add water into a double bond, and the product of that is an alcohol. Okay, so a very useful reaction. You can take any alkene, and in the presence of acid catalysts and water, usually there has to be a lot of heat involved. That's why you need steam and concentrated acids such as sulfuric acid. When you react those together, you will make an alcohol, okay, out of any alkene, and that's a hydration reaction. So water adds into that double bond to make the alcohol, okay? And then the last little topics that we have to discuss here is, if I have an alkene or an alkane, it could be a fluid. They all light on fire. They look pretty similar. How can I determine whether I have an alkane or an alkene? And a good test to distinguish that is that halogens, such as bromine, when you mix them with alkanes, they won't react unless you have UV light. Remember that radical mechanism that I showed you in the alkanes unit? Well, alkenes, on the other hand, if you add bromine in at room temperature, they'll immediately react. So if you look at this diagram over here, the alkane, when you add bromine, and bromine is a brown solution, will stay brown. Whereas if you add that brown solution to any chemical that has an alkene in it, it'll automatically react and make a colorless solution. So we know that chemicals have alkenes in them if bromine becomes colorless when you add it to them. That's a bromine test for alkenes. It's a way of distinguishing alkanes from alkenes. Okay, and the last reaction is probably the one that the world is fighting the most right now, is because we love this reaction where we take alkenes and polymerize them to make plastics. Alkenes can react with themselves, so you got to be careful. If you have a bottle of alkenes, you want to make sure that they're stored in the fridge and it's not hot and you don't have any radicals forming in them, so they got to be not exposed to UV light. If they're exposed to those things, the alkenes can react with themselves to form polymers. A polymer, as you can see in this diagram over here, a polymer is like a necklace where each bead is one of these ethene molecules that has reacted with another ethene. So a polymer is just a bunch of repeating units of beads or of ethene molecules. So the double bond in ethene can break and react with other alkenes. Usually you need a little bit of a trigger like UV light or some radicals in the mixture, and it'll cause the double bond of ethene to break, start reacting with the neighbor, which then causes a chain reaction, and then in the end you make a polymer. And this is usually, this that you can see down here is usually how we draw it on paper. A polymer is a repeat, it's a molecule that has a bunch of repeating units of the monomer, and this would be ethene. You don't see the double bond because the double bond broke and attached to another ethene molecule to make a fully saturated, long hydrocarbon chain that becomes solid and plastic. So your regular plastic looks like this. Now this would be a very brittle plastic. I can make it a little bit looser by adding alkanes into the double bonds and polymerizing them. So people that work with rubber and plastics will play around with these chains that attach to each monomer when they react. And that's basically it. So I'm going to be giving you guys a bunch of small worksheets to work through these reactions, identify them, and tell me what the reagents are. You don't have to know as much as the details I told you, but you definitely have to be able to identify these reactions and tell me for the unit test. Okay, good luck.